This is another example where we are given a logic circuit and we have to come up with its truth table and Boolean expression. However, there's a difference here that now we have 3 inputs and not the usual 2. Therefore, the number of inputs combination is going to increase from 4 to 8. There's a trick how to write down the inputs, the input combinations in order. And I am going to start by explaining that trick. So let's do the truth table. And the inputs are A, B, and C. We will write the intermediate outputs later on. All you have to do is to take a pencil and write down the binary weights on these letters. So 1, 2, and 4. Those are the binary weights. So 1, 2, and 4. Now, all you have to do is to start from the largest one, the 4, and to write down 4 zeros followed by 4 ones. Then, alternating, in the next column, we write 2 zeros and 2 ones. And in the last column, we write alternating 0 and 1. So that is the trick of how to write down the input combinations for any given number of inputs. If you have, say, 4 inputs, then the 4th column will have a weight of 8. And in that case, you write 8 zeros and 8 ones. Now, let's do this logic circuit. So I am going to name the intermediate outputs. So we have A, B, C. This one will be D, E, and F. So I'm going to write down the remaining labels here. So D, E, F, and X. And we can start filling in this truth table. So D, let's start with column D. D is not of A. Here A will have 4 zeros and 4 ones. So if it's not, it's the opposite. Therefore, we write 4 ones and 4 zeros. E is also a NOT gate. It's the NOT of C. So when we have a 0, we write a 1. When we have a 1, we write a 0. F is an AND gate, and it's the AND of D. So it's this column. And B. So it's that column. So now we have to focus on these two, on this column and this column, and work out the AND gate. Remember, when we have an AND gate, if there's a 0 in the input, the output is always a 0. For the output to be 1, we have to have both inputs or all inputs set to 1. So in this case, we have 0, 0. Here, both of them are 1, so the output is 1. The same here, 0, 0, 0, and 0. Now let's find the final output x. Now x is an OR gate, and it is the OR for this one. So f is the OR of this one, so b, and it's the OR for this one, e. So now we have to ignore this. We have to ignore that one. And since it's an OR, if there is a 1 in either B or E or F, the output is 1. Otherwise, if all three of them are 0, the output is 0. In this case, we have a 1 here, 0, 0, and 0, so it's a 0. Here we have 1s, the same here, 0, 0, 1, and 0, so it is 1, 0, 0, 0, so it is 0, 1, 1, 0, so it's 1, and here we have 1, 0, 0, so it's 1. And therefore this is the final answer for the truth table of this logic circuit. Now if we have to do the Boolean expression, as usual, we take a pencil and we write down the intermediate or the output for each logic gate. So here we have not, so this is a not. Here we have an AND gate, but it's the AND of this, and this is a not, and this, which is B. Here we have this, which is another NOT gate, so this is the NOT of C, therefore C NOT. And here we have this OR gate, and this OR gate is basically the OR of this one, so A and A NOT and B, or this input here, which is B, or this other input, which is C NOT. Therefore, the Boolean expression for this one, I'm going to write it here. The Boolean expression is x equals not A and B, or B, or C naught.